All right, so it says the height y in feet of a baseball t seconds after it is hit can be modeled by that function, negative 16t squared plus 96t plus 3. And it asks us to do a couple different things. We have four tasks we want to do. We'll do them one at a time. Okay, bless you. First says find the maximum height of the baseball. So guys, I think that it's helpful on these types of problems to draw a little picture so we can kind of get a sense of what's happening. All right. So we're playing baseball. Here's my baseball player. They got a bat and a hat. Really long hat. No, the hat's not important. So we just swung this bat, hit a baseball, and the baseball went flying. Okay. I need more room here. Oh, come on. Why do you think it looks like Jesus? Why? It's not a cross. Oh, because of the hat? Oh. The cross was probably a little bit bigger than that. It was big enough for him to hang on. I'm recording this, by the way. Okay, so the ball flies through the air. That's the picture. It's a bad picture, but it's a picture nonetheless. It says find the maximum height. Where does the maximum height happen? The vertex. Remember, maximum. That means vertex. So the maximum happens right up here. All right, do you remember how to find the vertex? Uh-oh. Let me ask you this. What form of a quadratic function is that? Standard form. It's in standard form. There's a fancy-dancy equation to find the vertex in standard form. Well, first you got to find the axis of symmetry. Yep. X equals negative b over 2a. So that's how you find the axis, right? So let's go ahead and do that. What is b? 96. So it's negative 96 over 2 times a. And what's a? Negative 16. All right, so that's negative 96 divided by negative 32. Somebody do that in a calculator. What is it? 3? I could have done that in your head. It's 3. That's the axis of symmetry. That's not the vertex. That's the axis of symmetry. So where is that on the graph? Like right here? But what is it? It's a line, right? And that happens at 3. What variable is on the x-axis? What's on the x-axis? T? And what does T mean? Seconds. So on the x-axis, we got time. What's on the y-axis? Height. Okay. So what does this mean? This is 3 seconds later, right? 3 seconds later, the ball's up at the max height. We don't know what the max height is. We just know when it gets there. How do you find what the max height is? Yeah, I'm going to take 3 in. Let's say 3 seconds into the flight of the ball. Let's find out how high it is. So I got to plug 3 into my equation, and I am out of room. Oh, gosh. You guys are looking for an excuse today. It's negative 16 times 3 squared plus 96. Oops. Plus 96 times 3 plus 3. Now it's just a bunch of calculator work, right? So somebody crank that out for me in a calculator. You got to do orders of operations. So you got to do 3 squared, which is 9. So multiply that by 9. Oh my gosh, why do I keep doing that? Somebody cranking it out? 147. So we put that on a calculator, you get 147. That means up here, 3 seconds in, you are 147 feet up in the air. So the max height, yep, the max height is 147 feet. Not bad. And it took you 3 seconds to get there. Does that make a little bit of sense? But in order to find that, we had to find the vertex. And in order to find the vertex, we had to find the axis of symmetry. In order to find the axis of symmetry, we needed this equation, right? So all the stuff that we've been talking about still applies, doesn't just go away. All right, next task. It says, how long does the ball take to hit the ground? Why would you say that? Because 3's in the middle. So you might think, well, 3 seconds in, it's like halfway through, so maybe just 6 seconds later, it'll hit the ground. It's not a bad thought. I would say that just doubling the axis is not going to be 100% accurate. Why am I saying that? Why would it not be 100% accurate? It's not that simple. It could come faster on the way down. Maybe there's some wind. I don't know. Ooh, there you go. It didn't start exactly at the ground, right? We hit it when it was off the ground. If we were talking about like a fake situation where, like if this was happening in a, has anybody ever taken a physics class? Is anybody in a physics class right now? Okay, traumatic. In physics class, they like to talk about stuff happening in a vacuum, which means like real life doesn't apply. So there's no air, there's no wind, there's no gravity, there's no like, you know, extenuating circumstances that might impact the situation. If we're talking about a vacuum, then yeah, you could just double this and it'd be 6. But that's not how life works, right? Sometimes stuff happens. There might be wind. I don't know. So we got to figure it out somehow mathematically. Let's think about our picture again. The ball hits the ground over here. What is that on our graph? It's an x-intercept. That's one of the x-intercepts. How do you find the x-intercept of a quadratic function? This thing? That'll tell you whether or not the x-intercept is a real number. We got to solve it, right? All week we've been talking about finding the x-intercepts. That's solving. That's solving a quadratic equation. So in order to find how long it takes to hit the ground, we need to solve it. We have options for this, right? You can factor, you can complete the square, you can solve with square roots. Here's our equation. Do you want to try to factor this? I don't. Those are big numbers. I don't want to deal with that. Do you want to try to complete the square with that? No. We can't do square roots because there's more than one variable, so we're only left with one option. What is it? Everybody's favorite thing. So we got to solve this thing using the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Does anybody have it memorized yet? Remember the thing from yesterday? You got it down? All right, let's do it. We need A, B, and C. Here's A, here's B, here's C. So let's write them over here just so we can see them.
So the first, the letter A of the problem is just finding the vertex. It's like what we started.
This part? Yeah. Yeah. I got A, B, and C. Do you guys think you can do this on your own? Those are big numbers, you sure? It's the same thing, it's just big numbers. Use your calculator, try it. Try it on your own. Take a couple minutes, see if you can solve this. All right, so did you guys get to here? You got to the square root of this big ugly number. Okay, so I told, normally we would, look for our perfect squares. We would try to break this thing down. And that's fine, but I want to know how long it takes. So, like, let's say you have a job someday where you actually talk about, like, launching missiles. Maybe you're doing, like, a test launch or whatever, I don't know. And your boss asks you, how long is it going to take for the missile to hit the ground? And you say, well, if my calculations are correct, it's going to take you negative 96 plus or minus 5i times the square root of 7 divided by negative 32 seconds. And your boss is going to say, what is that, right? So normally we simplify this, but I want to know what it is. Like, I want to know how many seconds it takes. So when we're in this kind of real life scenario, you want to get this number. It's going to be an ugly number, but you want to know what it is. So do you guys know how to take square root in your calculator? If you're on the phone, you might have to turn it sideways. By the way, you should stop using your phone as a calculator. Ugh, don't even talk about that. Square root of 9,408. Did this thing just die? Are you serious? My calculator just died. Well, just tell me, what's the square root of 9,408?
96.9948455.
What? Did you say minus?
No, I said 96.
Oh. 96.99 about? We don't need to go that far.
Oh.
Well, it's 99, right? Somebody asked me if I can round that up to 97. I would say don't round it up to 97 because that might be the difference in like a couple of seconds. You might not think so, but if you round this up even just a little bit, that might change your calculation by like half a second. And if you're talking about a missile or a ball, I don't know, whatever, you want to know, right? You want to be as accurate as you possibly can be. So try not to round that much. We want to be accurate here. All right, so I'm going to give myself more space on this. Here's what we do next. This is two numbers, right? It's negative 96 plus that. And it's negative 96 minus that.
Okay, I have a question.
What?
So one of the x's are going to be negative.
Yep. Let's figure out which one it is first.
So we cannot use that point in time.
Yeah. If you do this, negative 96 plus that divided by negative 32, what do you get? Like negative 1 over something? Negative 0.003?
Negative 0.03.
Okay, and what about this one? 6.03? All right, so these are the two numbers I end up with. One of those makes sense, one of those doesn't. Which one doesn't make sense? Why not? We're talking about time, right? Yeah, it doesn't take negative 0.3 seconds. That doesn't make any sense. So it is this one. It takes 6.03 seconds. What? One of them will be obvious. Yeah. That make a little bit of sense? Okay. All right, we have 2 more tasks, and then I'm done talking at you. I know I said it was only one problem, but it's a long problem. All right, now it asks me, when is the ball 85 feet high? Well, let's think about our function. This is the function. I want to know, when is the ball 85 feet high? So what am I given here? I'm given 85 feet high. I'm given a y, right? Because y is the height. So I am told that y needs to be 85. So what do you think we're going to do? What do you mean solve it out? Plug in y to your equation. Okay. So where is the equation? Do I have it written down somewhere? I'll just write it again. It's y equals negative 16t squared plus 96t plus 3. So I got to take 85 and plug it in for y. 85 equals all this stuff. Now I need to solve that. Well, what are you going to have to do? You got to solve it. If you're going to solve a quadratic, first thing you got to do is get everything on the same side, right? So I need to subtract this 85 over there. So that would be 0 equals negative 16t squared plus 96t. And what's 3 minus 85? Okay. So here's your quadratic. We need to solve that. Factoring, complete the square, square roots. We already talked about this, right? You don't want to do any of those. So we're going to have to do this again. Woo! For sake of time, guys, we're not going to carry this one all the way out. But you would use quadratic formula. You would use the quadratic formula to solve it again, and then you'd be done. Does that make a little bit of sense? All right, last piece, and then I'm done talking. It asks me, what is the value of the y-intercept? And what does it mean in this problem? Well, let's think about our situation. Brandon, you already talked about this a little bit. Where does the y-intercept happen? Remember what's going on? It's where he hits the ball, right? He hits the ball, that's when it starts. That's the starting point of the ball's trajectory. You know how to find that based on our function, what the value is? Pretty easy, don't overthink it. It's just C, because at what time does he hit it? 0. So we'd put in 0 for t. That stuff would just go away, and you're just left with your last value. So he hits the ball at 0. If you put 0 in for t, this stuff goes away, and all you have is 3, or the c value. So the y-intercept is c. What does it mean? Well, we already talked about that a little bit. It's the height at which he hits the ball.